The Milky Way is more than the glowing band that stretches across the night sky. It is our cosmic home, an immense spiral galaxy swirling with hundreds of billions of stars, planets, and mysteries. When we look up on a clear, moonless night, we are gazing through one of its spiral arms, seeing the light of distant suns that together form a faint river of starlight. This soft glow, once thought to be a celestial mist, is in fact the combined brilliance of countless worlds scattered across a vast disk tens of thousands of light-years wide. The Milky Way is both familiar and unfathomable. We live within it, yet we have only begun to understand its structure, origins, and place among the galaxies of the universe. Our galaxy spins like a cosmic whirlpool, its stars orbiting a mysterious center that hides a supermassive black hole. Around this luminous disk lies a halo of dark matter and ancient stars, and far beyond that, small satellite galaxies drift like silent companions. Every part of the Milky Way, its stars, gas, dust, and invisible forces, plays a role in the grand cosmic dance that has continued for over 13 billion years. It is a galaxy shaped by collisions and creation, by the birth and death of suns, and by the quiet pull of gravity that binds everything together. To study the Milky Way is to explore our own origins. The atoms in our bodies were forged in the stars that once lived and died within this galaxy. Every glance at the night sky is a glimpse into the vast system that made life possible. A reminder that our world is just one small spark in a sea of light. The Milky Way is not merely a backdrop for our existence. It is the grand stage upon which the story of the cosmos and of humanity itself unfolds. The Milky Way galaxy stretches across the night sky like a river of light, a shimmering band that has fascinated humankind for millennia. To the naked eye, it appears as a faint, cloudy path, but within that pale glow lies a staggering truth. The Milky Way is estimated to contain between 100 and 400 billion stars. This range, broad as it may seem, is a reflection of both the galaxy's immense complexity and the limits of our current understanding. Every star, from the smallest red dwarf to the most massive blue giant, contributes to the grand architecture of this spiral system that spans roughly 100,000 light-years across. When we speak of billions of stars, it is difficult to grasp the enormity of that number. Even the lower estimate, 100 billion, represents more suns than there are grains of sand on many of the world's beaches. Each of these stars burns with its own story, its own potential for planetary systems, and perhaps its own form of life. The diversity among them is as breathtaking as their sheer quantity. Some are ancient, formed not long after the galaxy itself coalesced around 13 billion years ago. Others are newborn, emerging from clouds of dust and gas in the galaxy's spiral arms, glowing with the energy of new creation. Together, they compose a cosmic symphony of light and gravity that holds the Milky Way together. Our solar system resides on the inner edge of one of the Milky Way's spiral arms, the Orion Arm, about 27,000 light-years from the galactic center. From this vantage point, we see only a fraction of what the galaxy contains. Much of its population is hidden by interstellar dust or lies too far away for our telescopes to resolve. Astronomers use various methods to estimate the number of stars, from studying the brightness and mass of different regions to mapping the galaxy's structure through infrared and radio observations. Even with these advanced techniques, the precise count remains uncertain. The difference between 100 and 400 billion may seem vast, but in cosmic terms, both figures speak of abundance on an almost incomprehensible scale. Among these stars are countless planetary systems, billions of worlds orbiting their suns, each potentially unique. The discovery of exoplanets over the past few decades has revealed that planets are not rare accidents of nature, but rather a common outcome of star formation. If each of the Milky Way's stars hosts even a few planets on average, the number of worlds could easily reach into the trillions. Such immensity deepens the mystery of our own existence, suggesting that Earth, while precious, may be one of many places where nature's creativity unfolds. Yet the stars are only part of the Milky Way's story. Interstellar gas and dust weave through its arms, birthing new generations of stars as older ones fade and die. Dark matter, an invisible but dominant component, surrounds and permeates the galaxy, shaping its rotation and structure through gravity's unseen hand. At the center lies Sagittarius A*, a supermassive black hole containing the mass of about 4 million suns. This gravitational anchor influences the orbits of stars near the core and serves as a reminder of the extremes that exist within our galactic home. To think of the Milky Way as containing hundreds of billions of stars is to confront both the vastness of the universe and our own smallness within it. And yet, within that smallness lies a remarkable connection. Every atom in our bodies was forged in the heart of a star, perhaps one not unlike those countless billions that shine in the galactic night. When we gaze up at the Milky Way, we are not merely looking at the stars, we are looking at our origins and perhaps our future. The Milky Way, our spiral home adrift in the vast ocean of the cosmos, is a galaxy alive with motion, color, and possibility. It is estimated to contain not only hundreds of billions of stars, but also an astonishing number of planets. Perhaps as many as 100 billion or even more. This idea, both humbling and exhilarating, has transformed humanity's understanding of its place in the universe. For much of history, the existence of planets beyond our solar system was a matter of speculation and imagination. Today, it is a well-established reality, supported by decades of astronomical discovery and the steady hum of data from telescopes orbiting high above Earth. The story of how we came to believe in this abundance begins in the late 20th century, when the first confirmed exoplanet, a planet orbiting a star other than the Sun, was discovered in 1995. That single discovery broke open a cosmic door. In the years that followed, missions like NASA's Kepler Space Telescope revealed that planets are not rare phenomena, but rather common companions to stars. Kepler's careful measurements of tiny dips in starlight, caused by planets passing in front of their host stars, allowed astronomers to infer the presence of thousands of worlds across a wide range of sizes and compositions. From small, rocky planets not much larger than Earth to immense gas giants that dwarf Jupiter, the diversity of these worlds has surpassed every expectation. When astronomers say there may be 100 billion planets in the Milky Way, they are not speaking metaphorically. The number is based on careful extrapolation from the data we have. If, on average, each star in our galaxy hosts at least one planet, and many appear to have several, then the total number of planets could easily exceed the number of stars. Even the most conservative estimates suggest that the galaxy is overflowing with worlds. Some orbit close to their stars, scorched by relentless heat. Others wander far beyond the warmth of any sun, frozen and lonely in the dark. A few lie in what scientists call the habitable zone, where conditions might allow liquid water to exist, an essential ingredient for life as we know it. This realization that our galaxy is teeming with planets reshapes our sense of cosmic possibility. For centuries, humans imagined the Earth as a singular oasis in an otherwise barren expanse. Now, the evidence suggests that our solar system is one of countless others, and that Earth is but one world among billions that may harbor oceans, atmospheres, or even life. The night sky, once thought of as a scattering of distant suns, is in truth a map of potential homes, each point of light perhaps encircled by its own family of worlds. This knowledge carries both wonder and perspective. It expands the universe while also drawing us closer to it, making us participants in a grand cosmic pattern rather than isolated observers. Yet for all we have learned, so much remains unknown. Most of the planets we have discovered are hundreds or thousands of light years away, too distant for us to study in detail. Their skies, their surfaces, their climates. These are mysteries we can only infer from faint signals of light. Future missions and telescopes, designed to capture the faint glow of distant worlds directly, promise to deepen our understanding. Perhaps, one day, we will detect the signature of life in the atmosphere of a distant planet, a whisper from across the galaxy telling us that we are not alone. To contemplate 100 billion planets in the Milky Way is to imagine a universe filled with endless stories, worlds forming, colliding, freezing, and burning, each one a unique expression of the same cosmic forces that shaped our own. It reminds us that creation is not confined to our corner of space. It is the rule, not the exception. The more we learn about these other worlds, the more we come to see our own not as the center of the universe, but as one bright thread woven into an infinite cosmic tapestry. The Milky Way, the galaxy that shelters our sun and all the familiar stars of the night sky, is a colossal structure, an island of light adrift in a sea of darkness. Astronomers estimate that it spans roughly 100,000 to 120,000 light-years from edge to edge. To comprehend such a distance is almost impossible. A single light-year, the distance light travels in 1 year, equals about 9.46 trillion kilometers. Multiply that by 100,000, and the scale of our galaxy begins to defy imagination. It is a realm so vast that even at the speed of light, it would take 100 millennia to journey from one side to the other. Within this enormous span lies everything we can call home. Our solar system, the billions of other stars, countless planets, and immense clouds of dust and gas that give birth to new suns. This immense size is not immediately apparent to us because we live deep within the Milky Way's disk, about 27,000 light-years from the galactic center. From our vantage point, the galaxy stretches around us like a great celestial ring. The band of faint light we call the Milky Way in the night sky is actually the view along the plane of this disk, where stars are densely packed and their combined light merges into a glowing river. Ancient observers, long before telescopes or measurements, gazed upon this band and wove myths to explain its brilliance. Stories of divine pathways, spilled milk from a goddess's breast, or a bridge between life and the afterworld. Only in the modern age have we learned that what they saw was the edge-on view of a spiral galaxy so immense that our entire solar system occupies only a tiny fraction of its breadth. The Milky Way's vast diameter encompasses a complex structure. A dense central bulge filled with old stars, a bar-shaped core of bright, fast-moving stellar clusters, and sweeping spiral arms that curl outward, containing younger stars, nebulae, and regions of active star formation. Surrounding this disk is a faint halo composed of ancient stars and mysterious dark matter, the invisible mass that exerts gravitational influence far beyond the reach of light. Even though we speak of the galaxy as being around 100,000 light-years wide, its true boundaries blur into space, where its gravitational influence continues much farther. Some studies suggest that the Milky Way's faint outskirts, if counted, may extend nearly twice that distance, though the edges grow ever more diffuse and difficult to define. The methods by which astronomers have measured this vastness are remarkable in themselves. Because we cannot step outside our galaxy to see it directly, scientists rely on indirect means, mapping the positions and velocities of stars, tracing the distribution of hydrogen gas through radio waves, and observing the motions of globular clusters that orbit the galactic center. From these patterns, a picture of the Milky Way's scale emerges. A flat, rotating disk that spans roughly 100,000 light-years, with our Sun situated in one of its minor spiral arms. It is a bit like trying to measure the size of a forest while standing among the trees. What we cannot see, we infer from patterns of motion, light, and shadow. The immensity of this galactic span carries a humbling message. Across those 100,000 light-years, hundreds of billions of stars are scattered like grains of sand, each with the potential to host planets, moons, and perhaps life. The distance between the stars is so great that even messages traveling at light speed would take years, centuries, or millennia to cross from one to another. Within this immense arena, our entire solar system is just a speck, orbiting the galactic center once every 230 million years. A single rotation in a life cycle that began billions of years ago and will continue for billions more. To say that the Milky Way is 100,000 light-years across is to describe a structure both vast and intimate. Vast because it contains unthinkable distances and countless worlds. Intimate because it is, quite literally, our home. Every star we see in the night sky belongs to this immense system. Every atom in our bodies was forged from its stars, and every direction we look reminds us that we dwell within a galaxy of staggering scale and quiet beauty. A cosmic city of light, wide enough to hold all the wonder our minds can imagine. The Milky Way, vast and ancient, stretches more than 100,000 light-years from one side to the other, yet compared to its immense width, it is astonishingly thin. In most regions, the galactic disk is only about 1,000 light-years thick, a fragile sliver of starlight and dust suspended in the darkness of space. This thinness gives the Milky Way its elegant, flat shape, like a luminous spiral coin spinning silently in the void. When we look up at the night sky and see that faint Milky Band arcing overhead, we are gazing along the plane of this disk, peering through its dense midsection where billions of stars, nebulae, and gas clouds lie stacked within a relatively narrow vertical space. The thinness of the Milky Way is not immediately intuitive. It contains hundreds of billions of stars, yet these stars are distributed in a way that makes the galaxy appear almost two-dimensional when viewed from afar. Most of the galaxy's stars, including our own Sun, orbit close to the central plane of the disk, their paths confined by the balance between gravity and motion. This delicate equilibrium keeps the stars from wandering far above or below the galactic plane, giving the Milky Way its remarkably flattened form. The disk is not perfectly uniform, of course. It ripples and warps slightly, like a vast sheet of fabric stirred by invisible winds, but overall, it remains a thin, rotating structure surrounded by a much more diffuse halo of older stars and dark matter. To understand the scale of this, imagine the galaxy as a dinner plate more than a meter wide but only a few millimeters thick. All the stars we see in the night sky, every nebula and cluster familiar to our telescopes, exist within that slim layer. Our solar system itself resides within this thin disk, about 27,000 light-years from the galactic center, orbiting in the Orion Arm, a small spur of one of the Milky Way's major spiral arms. If we could look at our galaxy from the side, we would see a narrow band of light bisected by dark streaks of dust, glowing faintly against the blackness of space. This side-on perspective reveals how truly slender the galactic disk is, especially when compared to its enormous diameter. The reason the Milky Way is so thin lies in its formation and the laws of motion that govern rotating systems. Billions of years ago, the galaxy formed from a vast, slowly spinning cloud of gas and dark matter. As gravity pulled the material inward, the rotation caused it to flatten, much as a spinning ball of dough becomes a disk. Over time, this flattened structure became the galactic plane, where most of the mass and star formation now occur. Stars born within the disk inherit this motion, moving in nearly circular orbits that keep them confined to the same narrow layer. Only older stars, those that have experienced gravitational disturbances over billions of years, tend to stray farther from the midplane, forming a thicker, more diffuse component around the disk. Despite its relative thinness, the galactic disk is far from empty. It is a place of dynamic activity, a rotating ocean of gas, dust, and stars, constantly churning under the influence of gravity. Within its 1,000 light-year thickness, new stars are born in dense molecular clouds, while others die in supernova explosions, seeding the surrounding space with heavier elements. These processes shape the structure of the disk over time, creating ripples, flares, and subtle warps that give the Milky Way its living, evolving character. Even the thinness itself is not perfectly even. In some outer regions, the disk thickens slightly, curving upward like the edge of a warped record. When we consider the galaxy's proportions, its thinness becomes one of its most graceful features, a sign of the delicate balance that governs cosmic systems. The Milky Way's flat form allows it to spin efficiently, to sustain the spiral arms that wind outward from its bright center, and to cradle the billions of stars that make up its glowing disk. For all its vastness, it remains an exquisitely refined structure, immense in diameter, yet finely layered, a cosmic sheet of light stretched across the depths of space. To live within such a galaxy is to inhabit something at once immense and slender, ancient and dynamic. A galactic plane only 1,000 light-years thick, but wide enough to contain all the stars we can see and all the stories they inspire. At the very heart of the Milky Way, hidden behind clouds of interstellar dust and gas, lies an extraordinary and mysterious object, Sagittarius A*, a supermassive black hole. It sits in the constellation Sagittarius, near the point where the spiral arms of the galaxy converge, anchoring the Milky Way's structure through its immense gravitational pull. Though completely invisible to the human eye, since no light can escape its grasp, its presence is unmistakable. Sagittarius A* exerts such a powerful influence that stars near the galactic center orbit it at breathtaking speeds, some completing their paths in mere years, a remarkable feat considering the vast scales involved. From these motions, astronomers have inferred that this dark object contains the mass of about 4 million suns packed into a region no larger than our solar system. The existence of Sagittarius A* was not known for most of human history. For centuries, the galactic center appeared as nothing more than a thick patch of the Milky Way's glow, obscured by dense clouds of dust that blocked visible light. It was only with the advent of radio astronomy in the mid-20th century that scientists discovered an unusually bright radio source in that region, which they named Sagittarius A. Later, as technology improved, astronomers began to observe stars orbiting around what appeared to be an invisible center. The way these stars moved, accelerating dramatically as they approached a single point before swinging back again, revealed the presence of an object with immense gravity but no visible form. There could be only one explanation that fit the data: a supermassive black hole. Sagittarius A* is not a black hole in the destructive, science fiction sense of the word. Though it has the power to trap anything that comes too close, it is, in many ways, the quiet heart of our galaxy. It does not devour stars regularly or shine with the furious energy of active black holes found in distant galaxies. Instead, it rests in a state of relative calm, feeding only occasionally when clouds of gas or stray debris wander into its reach. When this happens, the material heats up as it spirals inward, producing bursts of radiation that briefly illuminate the region before disappearing into darkness. These moments of activity allow astronomers to glimpse the environment around the black hole and to study the behavior of matter under extreme conditions. The first direct image of Sagittarius A* was captured in 2022 by the Event Horizon Telescope, a network of observatories spread across the globe that effectively functioned as a planet-sized telescope. The resulting image, an orange ring of light surrounding a dark central shadow, was a triumph of human ingenuity. It confirmed what had long been theorized, that a supermassive black hole truly lies at the center of our galaxy, shaping the motion of stars, influencing the structure of the Milky Way, and serving as a reminder of the powerful forces that govern the universe. Despite its invisible nature, Sagittarius A** is a vital part of the galaxy's life and history. Astronomers believe that supermassive black holes play an essential role in the evolution of galaxies, regulating the formation of stars and shaping the distribution of matter over cosmic timescales. The Milky Way, with its graceful spiral arms and calm, rotating disk, owes much of its stability to the gravitational center provided by this hidden giant. Without it, the stars near the galactic core would move chaotically, and the balance that holds the galaxy together might not exist in the same form. To think that at the heart of our galaxy, so vast that it takes 100,000 light-years to cross, lies a single object only a few times larger than the orbit of Mercury is both humbling and awe-inspiring. Sagittarius A** is a paradox of creation and destruction, an invisible engine of gravity that silently shapes the Milky Way. Around it, stars blaze, gas clouds swirl, and time itself seems to bend. And though it will never reveal its face, its presence is woven into everything we see when we look up at the night sky. The galaxy turns around this dark heart, a reminder that even in the deepest silence of space, power and beauty coexist in perfect balance. The Milky Way galaxy, vast and radiant, has existed for nearly as long as the universe itself. Astronomers estimate that it is about 13.6 billion years old, a span of time so immense that it is almost beyond human comprehension. This age places the Milky Way among the oldest galaxies known, born not long after the Big Bang, which occurred about 13.8 billion years ago. In those early epochs, the universe was a turbulent sea of gas, dust, and dark matter, slowly cooling and condensing into the first stars and proto-galaxies. Out of that primordial chaos, through gravity's patient hand, our galaxy began to take shape. A faint spark in a newly forming cosmos that would one day give rise to stars, planets, and, much later, life. The story of the Milky Way's formation is one of constant change and evolution. In its earliest stage, it was not the elegant spiral we see today, but a rough assembly of smaller, irregular clumps of stars and gas. These early fragments, drawn together by mutual gravity, collided and merged over hundreds of millions of years, forming the galactic core that would become the foundation of the Milky Way. Within that dense center, the first generations of stars were born, massive, brilliant, and short-lived. When they died in supernova explosions, they enriched the surrounding gas with heavier elements, allowing later generations of stars like our Sun to form with the ingredients needed to create planets and, eventually, life. As the galaxy aged, it continued to grow through mergers and accretions, absorbing smaller neighboring galaxies and drawing in interstellar material. This process, both violent and creative, helped to shape the Milky Way's spiral structure and feed the formation of its disk. The scars of these ancient collisions still linger today, faint streams of stars that stretch across the sky, remnants of once independent galaxies now dissolved into the Milky Way's greater whole. Even now, the galaxy's evolution continues, as it slowly pulls in dwarf galaxies from its surroundings and prepares for a future merger with the Andromeda Galaxy, an event that will occur billions of years from now. The age of the Milky Way is not measured directly but inferred through the study of its oldest stars and star clusters. Some of the most ancient stars reside in the galactic halo, a spherical region that surrounds the disk. These stars are relics from the earliest times, containing very few heavy elements, a sign that they were born before the universe had been enriched by generations of stellar death. By studying these ancient stars and comparing their compositions and life stages to theoretical models, astronomers have concluded that the Milky Way must have formed roughly 13.6 billion years ago. In the oldest globular clusters, tightly bound swarms of ancient stars, time itself seems frozen, offering a glimpse into the galaxy's youth. 13.5 billion years is a span that dwarfs all human history, all geological eras, even the age of our solar system, which formed only 4.6 billion years ago. When the Milky Way was young, the Sun did not yet exist, Earth had not formed, and the universe was a far harsher and darker place. Over cosmic time, the galaxy has matured, transforming from a chaotic cloud of gas into a grand spiral system filled with structure and life. Stars have been born and have died in uncountable numbers. Planets have coalesced from dust, and on one small world orbiting an unremarkable star, consciousness arose and began to wonder at the immensity of it all. The age of the Milky Way tells a story not only of time but of endurance and continuity. For nearly 14 billion years, it has spun through the cosmos, carrying within it the remnants of the universe's first light and the seeds of everything to come. To gaze upon the stars of our galaxy is to look into the deep past, to see light that began its journey before the Earth was formed, before life existed, before humanity learned to wonder. The Milky Way's 13.6 billion years are a testament to the universe's patience, a reminder that from the slow unfolding of time, beauty and complexity emerge. We are the latest chapter in that vast story, born of ancient stardust, living in the quiet arms of a galaxy nearly as old as creation itself. The Milky Way, vast and luminous, does not drift through the universe in solitude. It is part of a small cosmic family known as the Local Group, a collection of more than 50 galaxies bound together by gravity. This group, stretching across about 10 million light-years, is our immediate neighborhood in the grand structure of the cosmos. Within it, the Milky Way shares space with its largest companion, the Andromeda Galaxy, and with a host of smaller, fainter systems known as dwarf galaxies. Though tiny on the scale of the observable universe, the Local Group is a dynamic, evolving system that offers a glimpse into how galaxies interact, grow, and shape one another over billions of years. At the heart of the Local Group are its two giants, the Milky Way and Andromeda, also known as M31. These two spiral galaxies dominate the group, containing the vast majority of its mass and stars. Each is surrounded by a retinue of smaller satellite galaxies, some of which orbit close by, while others wander farther out. The Milky Way's known companions include the Large and Small Magellanic Clouds, two irregular galaxies visible from the southern hemisphere, and several dozen dwarf spheroidal galaxies, such as the Sagittarius Dwarf and the Fornax Dwarf. These smaller systems are faint and fragile, often stretched and distorted by the Milky Way's gravitational pull. Andromeda, too, has its own cluster of satellites, including the Triangulum Galaxy, M33, which is the third largest member of the local group and may one day merge with Andromeda itself. The gravitational bonds of the local group keep its members connected despite the immense distances between them. While galaxies in the wider universe are generally moving apart due to cosmic expansion, the galaxies within the local group are held together by their mutual gravity, orbiting one another in a slow, intricate dance that has lasted for billions of years. The entire group is thought to be moving as a unit through space, drifting toward the Virgo cluster, a much larger assembly of galaxies that lies tens of millions of light-years away. Within this quiet galactic community, the Milky Way and Andromeda are on a slow but inevitable collision course. In about 4 billion years, they are expected to meet, merging into a single, larger elliptical galaxy that will mark a new chapter in the local group's history. The smaller galaxies that make up the rest of the group add to its diversity and texture. Many are dwarf galaxies, containing only a few million or a few billion stars, mere specks compared to the Milky Way's hundreds of billions. Some of these dwarfs are so faint that they were only discovered in recent years. Their stars spread thinly across the sky like faint whispers of light. These tiny galaxies are crucial to understanding galactic evolution, as they represent the building blocks from which larger galaxies like ours were formed. Over time, many of them are torn apart by tidal forces, their stars stripped and absorbed into the halos of the larger members. In this way, the local group continues to change, its galaxies interacting, merging, and reshaping one another in a slow cosmic cycle. Despite its name, the local group is vast beyond human imagination. The distance between the Milky Way and Andromeda, for example, is about 2.5 million light-years, so far that the light we see from Andromeda tonight began its journey long before modern humans existed. Yet, on the scale of the universe, where clusters of thousands of galaxies fill the cosmic web, our local group is relatively small and isolated. It sits on the outskirts of the Virgo supercluster, a much larger structure that in turn forms part of the Lania Chaos supercluster, a sprawling network of galaxies that extends across hundreds of millions of light-years. To know that the Milky Way belongs to the local group is to understand that we are not alone even on a galactic scale. Our home galaxy is one among many, bound by gravity and history to its neighbors, sharing in the quiet motion of a larger system. When we look up at the night sky and see the faint glow of the Andromeda galaxy, we are looking across the space that links our galaxy to another, a bridge of gravity and time that has connected them since their birth. The local group is our immediate cosmic family, a gathering of galaxies traveling together through the universe, each carrying its own stars, planets, and stories, bound forever by the invisible threads of gravity. The Milky Way, vast and ancient, is not a static collection of stars frozen in time. It is a living, evolving galaxy that continues to create new stars even after more than 13 billion years of existence. Deep within its swirling spiral arms, vast clouds of gas and dust collapse under the force of gravity, igniting the birth of new suns. Astronomers estimate that the Milky Way forms roughly 7 new stars each year, a quiet but persistent rhythm of creation that has continued for billions of years. Each of these newborn stars represents the renewal of the galaxy's energy, the continuation of the cosmic cycle that has shaped the universe since its beginning. Star formation is a delicate and intricate process. It begins in the coldest, darkest regions of the galaxy, where massive molecular clouds stretch across light years of space. These clouds, made mostly of hydrogen and helium, are often stirred by the shock waves of supernovae or the gravitational influence of nearby stars. When a region within such a cloud becomes dense enough, gravity takes over, pulling the gas inward until it collapses under its own weight. As the core of this collapsing region heats up, nuclear fusion begins, and a new star is born. Around it, leftover material may form planets, moons, and asteroids, giving rise to entire solar systems. In this way, every new star born in the Milky Way carries with it the potential for new worlds, and perhaps, far in the future, new forms of life. The rate of star formation in the Milky Way has changed dramatically over time. In its youth, the galaxy was far more prolific, producing stars at a much faster rate. Billions of years ago, when gas was more abundant and the galaxy was still assembling its spiral structure, thousands of stars may have formed each year. Today, the Milky Way's star formation rate has slowed, as much of its gas has already been converted into stars or expelled into intergalactic space. Yet even at its current pace, around 7 stars per year, the galaxy remains vibrantly active. Each year, in hidden nurseries scattered throughout the spiral arms, new light flickers into existence, joining the hundreds of billions of stars that already fill the galactic disk. The Orion Arm, where our solar system resides, is home to some of the most famous star-forming regions in the galaxy. The Orion Nebula, visible even to the naked eye, is a stellar nursery where hundreds of young stars are forming right now. Similar regions, such as the Carina Nebula and the Eagle Nebula, teem with energy as newborn stars carve cavities in their surrounding clouds with fierce radiation and stellar winds. These nebulae are among the most beautiful and dynamic structures in the sky, glowing reminders that the Milky Way is still creating new sources of light. The process is slow by human standards but constant on a cosmic scale. Every century, roughly 700 new stars come into being, each one destined to shine for millions or even billions of years before its life ends in quiet fading or spectacular explosion. Star formation is not only a process of creation but also one of recycling. When massive stars reach the end of their lives, they explode as supernovae, scattering heavy elements into space. These elements, carbon, oxygen, iron, and others, enrich the surrounding gas clouds, making future generations of stars and planets more complex. Our own sun, born about 4.6 billion years ago, carries within it the remnants of earlier stars that lived and died long before. Thus, when new stars form today, they do so from material that has been used and reused countless times, linking every star in the galaxy through the shared matter of creation. That the Milky Way still produces 7 new stars each year is a testament to its vitality. Despite its age, it remains dynamic, continuing the process that has defined it since its birth. Somewhere, in the quiet depths of a nebula, a new star is flickering into existence at this very moment, one of 7 that will be born this year. Around it may one day form planets, perhaps even one like our own. The galaxy's pulse continues, steady and eternal. Each new star a reminder that the Milky Way, though ancient, is still alive with the light of creation. When we gaze up at the night sky, the stars we see belong to a single galaxy, the Milky Way, but beyond its shimmering disk lies an incomprehensible vastness. The observable universe, the portion of the cosmos we can detect with our instruments and telescopes, contains not just thousands or millions, but an estimated 200 billion to as many as 2 trillion galaxies. Each of these galaxies is a massive system of stars, gas, dust, dark matter, and planets, spinning and evolving through cosmic time. The sheer scale of this number stretches the imagination. It reminds us that what we perceive as the universe from our small corner of space is only the tiniest fraction of a reality almost beyond comprehension. This staggering estimate has grown as our technology and understanding have advanced. In the early 20th century, astronomers believed that the Milky Way might be the entire universe. The faint, fuzzy patches of light seen through early telescopes were thought to be gas clouds within our own galaxy. It was only in the 1920s, through the work of Edwin Hubble, that we learned these nebulae were, in fact, other galaxies, entire island universes far beyond our own. This revelation changed everything. The universe suddenly expanded from a single galaxy to a vast, populated cosmos. Since then, as telescopes have improved and space observatories like the Hubble Space Telescope have peered deeper into the darkness, our count of galaxies has continued to climb. The Hubble Deep Field, an image taken in the 1990s after pointing the Hubble Space Telescope at a seemingly empty patch of sky, revealed thousands of galaxies in an area no larger than a grain of sand held at arm's length. Later, the Hubble Ultra Deep Field and other deep space surveys pushed even further, detecting galaxies so faint and distant that their light had traveled for more than 13 billion years to reach us. From these observations, astronomers were able to estimate how many galaxies exist within the observable universe. Early estimates suggested around 100 to 200 billion, but as techniques improved in faint, small galaxies were included in the calculations. The number rose dramatically to as many as 2 trillion. Each of these galaxies holds, on average, hundreds of billions of stars, meaning there may be more stars in the universe than grains of sand on all the beaches of Earth. It is important to remember that the term observable universe refers only to the part of the cosmos we can see. Limited by the distance light has been able to travel since the Big Bang, roughly 13.8 billion years ago. Beyond that horizon, there may be more galaxies, perhaps infinitely more, receding faster than light can reach us. What we can observe, then, is only a small bubble within a potentially much greater reality. Even within this observable bubble, most galaxies are too faint and distant to ever be seen individually. Many are small dwarf galaxies, dim clouds of a few billion stars, while others are colossal ellipticals and spirals, each containing the energy and complexity of hundreds of billions of suns. The existence of so many galaxies also hints at the vast diversity of cosmic structures. Some galaxies collide and merge, giving birth to new generations of stars, while others drift alone in quiet isolation. Within them lie uncountable solar systems, exoplanets, and possibly countless forms of matter and life. The idea that there are 200 billion to 2 trillion galaxies transforms our perspective on existence. It makes our solar system, our planet, and even our galaxy feel like a small, precious speck in a grand cosmic ocean. It reminds us that creation is not a singular event but an ongoing process, playing out across unimaginable scales of space and time. When we look at the faint glow of the Milky Way across the night sky, it is easy to feel both humbled and inspired. That single band of light represents one galaxy among trillions, each one a vast island of stars drifting through the cosmic sea. Somewhere within those distant galaxies, light from unknown suns burns, unseen but real. The knowledge that our universe holds such abundance, hundreds of billions or even trillions of galaxies, invites awe, curiosity, and a deep sense of wonder. It tells us that the story of the cosmos is far larger than we can fully grasp, and yet we are a part of it, living beings made of the same stardust that shines in every corner of this infinite expanse. At the heart of the Milky Way lies a structure both powerful and beautiful, a vast bar of stars that stretches roughly 27,000 light-years across, cutting through the galaxy's central bulge like a luminous bridge. This stellar bar, composed of billions of stars along with dense clouds of gas and dust, forms the backbone of the galaxy's inner region. Though invisible to the naked eye from Earth's position within the galactic disk, astronomers have revealed its presence through infrared observations that can pierce the heavy veils of interstellar dust surrounding the core. The discovery of this bar reshaped our understanding of the Milky Way's structure, showing that our galaxy, like many others in the universe, is not a simple spiral but a barred spiral, its graceful arms spiraling outward from the ends of a central, elongated hub of light. The bar is more than just a striking feature. It is a dynamic engine that helps shape the entire galaxy. Stars within it move in complex orbits, pulled by the combined gravity of the galactic bulge and the disk. As they travel, the bar exerts a powerful influence on the surrounding material, channeling gas from the outer regions toward the center. This inward flow of gas fuels both star formation and the activity around the supermassive black hole, Sagittarius A*, that resides at the galaxy's heart. The process acts like a vast, slow-moving conveyor belt, drawing material inward and breathing life into the central regions of the Milky Way. The bar, then, is not merely a structural feature. It is a dynamic mechanism that helps sustain the galaxy's ongoing evolution. Measuring about 27,000 light-years from end to end, the central bar makes up more than a quarter of the Milky Way's total diameter. It dominates the inner tens of thousands of light-years, extending outward from the bulge and serving as the point from which the galaxy's major spiral arms emerge. Observations suggest that the Sun and Solar System lie just outside this central structure, far enough away that we cannot see it directly. From our perspective, dust and gas obscure our view of the galactic core, making it difficult to study in visible light. Only with the aid of infrared telescopes and radio observations, like those conducted by the Spitzer Space Telescope and other instruments, have astronomers been able to map the bar's true shape and size. These studies reveal a complex structure with a dense population of older, redder stars at its center and streams of younger stars stretching outward toward the spiral arms. Bars like this are not unique to the Milky Way. In fact, they are common throughout the universe, appearing in roughly 2/3 of all spiral galaxies. Astronomers believe they play a vital role in galactic evolution, redistributing material and angular momentum to shape the patterns of star formation over time. The Milky Way's bar is thought to have formed billions of years ago, as the galaxy's inner disk became unstable and elongated under the influence of gravity. Once formed, it became a semi-permanent structure, rotating slowly with the galaxy and continuously influencing its surroundings. The pattern speed of the bar, how quickly it turns relative to the rest of the galaxy, remains a subject of active research, as it holds clues about how the Milky Way's mass is distributed and how its shape will change in the future. The bar's motion and gravitational pull also help define the Milky Way's spiral arms, which seem to fan outward from its ends like ribbons of starlight. The Scutum Centaurus and Perseus arms, for example, appear to trace their origins to the tips of the bar. The regions near these ends are rich in star-forming activity, as the bar's gravitational influence compresses gas clouds and triggers the birth of new stars. Thus, the bar acts both as a sculptor and a catalyst, shaping the galaxy's structure and driving its continued growth. To imagine the Milky Way's bar is to envision an immense, glowing spindle at the center of a vast wheel, turning slowly through the cosmic dark. Within it, billions of ancient stars burn with steady light, marking the galaxy's core as a place of both mystery and motion. Stretching 27,000 light-years across, it anchors the Milky Way's spiral form and connects its inner and outer regions in a web of gravity and energy. Though we cannot see it with our eyes, the bar's presence defines the rhythm of our galaxy's heart, a grand, hidden structure that continues to shape the story of the Milky Way. The Milky Way galaxy, majestic and immense, is far more than a collection of stars. It is a vast ecosystem of matter and energy, composed of gas, dust, nebulae, dark matter, and star clusters, all working together in a grand cosmic balance. These elements form the building blocks of our galaxy, shaping its structure, fueling its evolution, and giving rise to the stars and planets that populate its spiral arms. Though we often imagine the Milky Way as a glittering band of light across the night sky, its true nature is far more complex. A dynamic tapestry woven from both visible and invisible threads. Interstellar gas is one of the Milky Way's most vital components. It fills the spaces between stars, forming enormous clouds of hydrogen and helium that serve as the raw material for star formation. Some of these clouds are diffuse, stretching for hundreds of light years, while others are dense and cold, collapsing under their own gravity to give birth to new stars. The cycle of gas is endless. Stars form from it, shine for millions or billions of years, and eventually return much of their material to space through stellar winds and supernova explosions. This continuous recycling enriches the galaxy with heavier elements: carbon, oxygen, iron, ingredients necessary for planets and life. In this way, the Milky Way is not a static structure but a living system, constantly renewing itself. Alongside the gas floats interstellar dust, a much smaller but no less important ingredient. These tiny grains, made of carbon, silicates, and metals, absorb and scatter light, shaping the way we see the galaxy. Dust creates the dark, smoky lanes that cut through the Milky Way's glowing disk, hiding vast regions of stars from view. Yet without this dust, planets like Earth could not exist, for it is within the dusty disks surrounding young stars that planets form. Dust also plays a crucial role in cooling gas clouds, allowing them to collapse more easily and give birth to new generations of stars. Thus, even in its obscuring darkness, dust is an agent of creation. Within the galaxy's disk and arms lie nebulae, the luminous, colorful clouds that mark both the birth and death of stars. Some nebulae, like the Orion Nebula, are stellar nurseries, glowing from the light of the young, hot stars forming within them. Others, like the remnants of supernovae, are the echoes of cosmic death, expanding shells of gas and dust ejected by dying stars. These nebulae enrich the interstellar medium with the elements forged in stellar cores, ensuring that each new generation of stars contains the ashes of those that came before. In their beauty lies the story of the galaxy's continual transformation. Beyond the visible components of the Milky Way lies something far more mysterious: dark matter. Though it cannot be seen, dark matter makes up most of the galaxy's mass, forming an invisible halo that extends far beyond the bright disk of stars. It reveals its presence only through gravity, influencing the motion of stars and the rotation of the galaxy itself. Without dark matter, the Milky Way's outer regions would spin apart, their stars flung into intergalactic space. Instead, this unseen substance holds everything together, an invisible scaffolding upon which the visible galaxy rests. Scattered throughout this immense system are the star clusters, spherical and open groups of stars bound together by gravity. Globular clusters, the oldest of these, orbit the Milky Way's halo like ancient sentinels, each containing hundreds of thousands of stars formed more than 10 billion years ago. Open clusters, by contrast, are smaller and younger, found mostly in the spiral arms where new stars are still being born. Together, they preserve the galaxy's memory, offering clues to its age, formation, and history. The Milky Way's richness lies in its complexity. Gas, dust, nebulae, dark matter, and star clusters are not separate entities but interwoven parts of a single vast organism. The galaxy breathes through cycles of creation and destruction, fueled by invisible forces and illuminated by the light of its countless stars. When we gaze upon the Milky Way in the night sky, we see only a fraction of its substance. But hidden within that glowing band is a story of matter endlessly reshaping itself, a cosmic dance that has been unfolding for nearly 14 billion years. The Milky Way, our galactic home, is far from stationary. Though it may appear still when we gaze up at the quiet canopy of stars, the entire galaxy is in motion, sweeping, turning, and gliding through the cosmic void at extraordinary speeds. Every star, nebula, and cloud of gas that makes up the Milky Way is part of this immense and continuous movement, carried along in a dance that has lasted for billions of years. The galaxy rotates around its center while simultaneously drifting through space, pulled and influenced by the gravity of neighboring galaxies and the unseen matter that fills the universe. To say that the Milky Way is moving is to recognize that even the grandest structures in the cosmos are never truly at rest. At its core, the Milky Way rotates. Every star, including our Sun, orbits the galactic center, completing one revolution roughly every 230 million years. This vast journey, known as a galactic year, means that since the formation of the solar system, our Sun has traveled around the Milky Way more than 20 times. The speeds involved are staggering. The Sun, for example, moves at about 220 kilometers per second, roughly 490,000 miles per hour, relative to the galaxy's center. Yet we do not feel this motion, for everything around us, planets, moons, and even the interstellar gas, moves in harmony, bound together by the same gravitational current. The galaxy's rotation keeps its spiral structure intact, its arms curving gracefully outward from the central bar, each star following a path shaped by gravity's invisible hand. But the Milky Way's movement does not stop with rotation. The entire galaxy itself is drifting through space, part of a grander motion within the local group of galaxies. Together with its nearest large neighbor, the Andromeda Galaxy, and dozens of smaller satellite galaxies, the Milky Way moves through the universe as part of a gravitationally bound cluster. This motion is complex, each galaxy both orbiting the group's common center of mass and influencing the others through mutual attraction. The Milky Way and Andromeda, in particular, are on a slow but inevitable collision course. Observations show that Andromeda is approaching us at about 110 kilometers per second, and in roughly 4 billion years, the two galaxies will meet and merge, forming a new, larger elliptical galaxy that will continue their journey as one. Beyond the local group, the Milky Way is also being pulled toward even larger structures. Our galaxy, along with the rest of the local group, is moving toward a massive region of space known as the Virgo cluster, part of the Virgo supercluster. This immense gravitational attraction exerts a steady pull on our galaxy, guiding its motion through the larger cosmic landscape. Even more broadly, the entire Virgo supercluster itself drifts toward an enormous gravitational anomaly called the Great Attractor, a dense concentration of mass located hundreds of millions of light-years away. The Milky Way, then, is not only rotating and orbiting, it is part of a vast, hierarchical web of motion that extends across the visible universe. The idea that everything is in motion changes the way we think about stability and permanence. From our perspective on Earth, the stars seem fixed, the constellations eternal. Yet they, too, are moving, each star tracing its own path through space, shaped by the galaxy's rotation and local gravitational interactions. Over millions of years, the familiar patterns of the night sky shift and fade as stars drift to new positions. The Milky Way's own motion carries us along this cosmic current, a journey so immense that human lifetimes barely register against its scale. To imagine the Milky Way's movement is to picture an ocean of stars flowing through the dark. Within its spiral arms, stars rise and fall in gentle oscillations as the galaxy turns. Its disk spins like a vast wheel, while the entire structure glides toward unseen destinations, guided by forces that have acted since the dawn of time. Though we cannot feel its motion, we are part of it, riding within the galactic current as the Milky Way sails through space at hundreds of kilometers per second. The stillness of the night sky, then, is an illusion. Beneath its quiet surface, the galaxy moves in silence, a vast and restless traveler on an endless journey through the universe. The Milky Way, our galactic home, is a grand spiral of stars, gas, and dust. An immense, rotating disk that stretches more than 100,000 light-years across. From within, it appears as a band of soft light across the night sky, but when imagined from afar, it would resemble a vast pinwheel, its arms curling gracefully around a bright, dense center. This spiral shape, so elegant and orderly, is the product of billions of years of cosmic evolution, a natural result of gravity's slow choreography on an immense scale. Each of the Milky Way's spiral arms is made up of countless stars and nebulae, weaving a structure both dynamic and alive, where creation and destruction occur in continuous rhythm. Though we cannot step outside the galaxy to see its form directly, astronomers have pieced together its shape through careful observation and mapping. By studying the movement of stars, the distribution of gas clouds, and the emission of radio waves from interstellar material, scientists have revealed that the Milky Way is a barred spiral galaxy. This means that at its center lies a bar-shaped concentration of stars, from which the spiral arms unfurl like ribbons of light. These arms are not solid structures but regions where stars are born more frequently, waves of density moving through the galactic disk, compressing gas and dust as they pass. New stars ignite in these regions, illuminating the spiral pattern with their brilliance, while older stars drift away into the quieter spaces between the arms. Our solar system lies on the inner edge of one of these arms, known as the Orion Arm or Orion Spur, located about 27,000 light-years from the galactic center. From this position, we are like travelers standing deep within a forest, able to see the trees around us but not the shape of the forest itself. The glowing band of the Milky Way that stretches across the sky on clear nights is the combined light of billions of distant stars seen edge-on through the galactic disk. For ancient peoples, this faint celestial river inspired myths and stories, a bridge between worlds, a pathway of souls, a reflection of the divine. Only in the past century have we come to understand that this river of light is part of an enormous spiral system, one of countless galaxies scattered throughout the universe. The spiral shape of the Milky Way is not static but in constant motion. The entire galaxy rotates, with stars near the center completing their orbits more quickly than those farther out. This rotation, combined with the gravitational influence of dark matter, helps maintain the spiral form over cosmic time. Yet the arms themselves are not permanent structures. They are patterns that persist as stars move through them, much like cars entering and leaving a traffic jam while the jam itself remains. Over billions of years, the galaxy has evolved, its spiral arms shifting and reshaping under the influence of gravity, collisions, and the ongoing birth and death of stars. To imagine the Milky Way's spiral form is to glimpse the balance between motion and stability, between the forces that tear apart and those that bind together. It is a structure born of time and gravity, of rotation and light, a living system that continues to evolve even as we observe it. Every star in the night sky, every cloud of glowing gas, every world orbiting a distant sun is part of this vast spiral, moving together through the quiet expanse of space. And as we look upward, tracing the Milky Way's faint curve across the heavens, we are In a sense, looking along the arms of our own cosmic home, participants in the graceful spin of a galactic dance that began billions of years ago and will continue for billions more. Among the countless stars that populate the Milky Way, one stands out for its immense size and almost incomprehensible scale, Uy Scuti. Located roughly 9,500 light-years from Earth in the constellation Scutum, this red supergiant is considered the largest known star in our galaxy by radius. It is so vast that if placed at the center of our solar system, its outer surface would extend beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, Mars, and the asteroid belt in its fiery atmosphere. In a universe filled with extremes, Uy Scuti embodies the limits of stellar expansion, a colossal beacon that illustrates both the power and the fragility of stars at the end of their lives. Uy Scuti is classified as a red supergiant, a type of star that represents one of the final stages in the life of a massive star. Having exhausted much of the hydrogen fuel in its core, it has expanded to an enormous size as it fuses heavier elements like helium into carbon and oxygen. This expansion causes its outer layers to cool, giving it a deep reddish hue and a diffuse, tenuous atmosphere. Unlike smaller stars such as the Sun, which maintains stable structures for billions of years, red supergiants are unstable, constantly shifting, pulsating, and shedding mass into space. Uy Scuti's surface is not a sharp boundary but a turbulent region of convective cells so large that they could contain entire planets. Its light flickers and varies in brightness over time, as the star expands and contracts in slow, rhythmic pulses that reflect the struggles of a dying giant. The measurements that classify Uy Scuti as the largest known star are staggering. Its radius is estimated to be around 1,700 times that of the Sun, though the exact number varies depending on the methods used to measure it. If it were hollow, more than 5 billion suns could fit inside its volume. Yet despite its incredible size, Uy Scuti is not the most massive star. Many others contain far more matter but occupy a much smaller space. Its density is extremely low, especially in its outer layers, where the gas is spread thin across a vast distance. In a way, Uy Scuti is less a solid sphere and more a glowing, tenuous cloud held together by gravity and radiation, poised on the edge of collapse. Observations of Uy Scuti have also revealed that it is surrounded by a shell of gas and dust, created by the steady outflow of material from its surface. Like many red supergiants, it is losing mass at a tremendous rate, blowing off layers of its outer atmosphere into space. This process enriches the surrounding interstellar medium with heavier elements: carbon, nitrogen, oxygen, and more, the essential building blocks of future stars and planets. In this sense, Uy Scuti's eventual death will not mark an end but a transformation, contributing to the ongoing cycle of cosmic creation. When its life finally ends, it is expected to explode as a supernova, briefly outshining entire galaxies before collapsing into either a neutron star or a black hole. Such an event would be one of the most spectacular displays in the galaxy, visible across great distances as a powerful burst of light and energy. To contemplate Uy Scuti is to confront the extremes of nature's creativity. The sheer scale of the star defies ordinary imagination. Its size dwarfs our sun to the point of absurdity. Its lifespan, though only a few million years, is a blaze of glory compared to the sun's steady 10 billion-year existence. Yet, for all its immensity, UY Scuti also represents impermanence. Its vastness is a sign not of stability but of decline, a swollen giant nearing the end of its cosmic journey. It stands as a reminder that even the mightiest stars live finite lives, bound by the same physical laws that govern every grain of matter in the universe. From our small planet, nearly 10,000 light-years away, UY Scuti appears as a faint point of light, unremarkable to the naked eye. Yet behind that tiny spark lies one of the greatest wonders of the Milky Way, a star so vast that it stretches the limits of what we can comprehend. In its burning heart and fading glow, it carries the story of stellar life and death, a story written in hydrogen, light, and time. UY Scuti, the giant of our galaxy, stands as both a marvel and a monument, a luminous reminder of the vast forces that shape the universe and the fleeting brilliance of even its greatest stars. Our solar system, with its familiar family of planets, moons, asteroids, and comets, resides in a modest corner of the Milky Way galaxy, a place known as the Orion Arm or sometimes the Orion Spur. It is a small, partial spiral arm nestled between two of the galaxy's larger and more prominent arms, the Sagittarius Arm on one side and the Perseus Arm on the other. From this unassuming location, about 27,000 light-years from the galactic center, we orbit quietly within a region filled with stars, gas, and dust. Though it may not seem like much on a galactic scale, the Orion Arm is our home within the Milky Way, a bright and active region where stars are continually born and where our sun shines as just one of billions. The Orion Arm stretches for thousands of light-years and is rich in the ingredients of cosmic creation. It contains many of the sky's most beautiful and well-known star-forming regions, including the Orion Nebula, from which it takes its name. Within this nebula, vast clouds of gas and dust are collapsing under gravity to form new stars, surrounded by disks that may one day give rise to planets. Other famous nebulae, such as the Rosette, the Lagoon, and the Eagle, also lie within or near the Orion Arm, marking it as a region of dynamic, ongoing change. These glowing clouds and clusters of young stars paint the arm with light, shaping the view we see when we look up at the night sky. Our sun is thought to have formed here roughly 4.6 billion years ago, from the collapse of a cloud of gas enriched by earlier generations of stars. Like countless others in this arm, it joined the grand rotation of the Milky Way, orbiting the galactic center at a speed of about 220 kilometers per second. One complete journey around the galaxy takes the solar system about 230 million years. A cosmic year measured not by months or days, but by the turning of the entire galaxy. During that time, the sun and its planets travel through regions of interstellar gas, pass near other stars, and drift gently through the dense star fields that make up the Orion Arm. From our position within this spiral structure, the Milky Way's appearance takes on its familiar banded form. When we gaze up at the night sky, we are looking along the flat plane of the galactic disk, peering through layers of stars, gas, and dust that stretch across thousands of light-years. Because we are embedded within one of its arms, our view of the Milky Way is that of a participant, not an observer. We cannot see the whole spiral form directly. Instead, we piece together its shape through careful mapping of distant stars and radio signals. These observations have revealed that the Orion Arm is not one of the galaxy's primary arms, but rather a smaller spur or bridge connecting two larger ones. Yet despite its modest status, it is rich with the raw material of life and light, and it is here that our story unfolds. The Orion Arm's position may be more than a coincidence. It may also be a blessing. Our solar system lies in a relatively calm region of the galaxy, far from the violent core where stars crowd together and black holes and supernovae release intense radiation. This quiet location has likely provided stability, allowing life to emerge and evolve on Earth over billions of years. In the vast machinery of the Milky Way, we occupy a middle ground, not too close to the galactic center, where chaos reigns, and not too far out in the cold, sparse reaches of the outer disk. It is a place of balance and light, where the galaxy's beauty is visible yet not overwhelming. To know that we live in the Orion Arm is to understand that our home is part of something far larger, a spiral of stars and matter that has turned for billions of years. The sun, the planets, and all of Earth's living things move together through this arm, bound by the same gravitational currents that guide the stars. Every night, when we look toward Orion's bright constellation, we are gazing toward the very region that gave our galactic neighborhood its name. A reminder that we are not separate from the galaxy, but a small, shining piece of its great and ongoing story. The Milky Way, vast and magnificent, appears from afar as a graceful spiral of light, an immense disk of stars and gas rotating around a luminous core. Yet despite this seemingly perfect symmetry, the galaxy is not flat. Its disk is warped, bent and twisted like a cosmic ribbon caught in motion. The outer edges curve upward on one side and downward on the other, forming a subtle but measurable distortion that gives the Milky Way the shape of a bent frisbee or a gently rippling wave. This warp, invisible to the naked eye but clearly revealed through modern observations, tells a deeper story about the galaxy's restless history and the invisible forces that continue to shape it. For centuries, humans saw the Milky Way only as a hazy band stretching across the night sky, unaware of its true form. Even when astronomers learned that we lived inside a spiral galaxy, they imagined it as a flat, even disk. Only in recent decades, through the use of powerful telescopes and precise measurements, have we discovered that this is not the case. By mapping the positions of distant stars, gas clouds, and interstellar hydrogen using radio waves, scientists have built a three-dimensional picture of the Milky Way, and it reveals that the outer regions are distinctly warped. The central part of the galaxy, near the bulge, remains relatively flat, but beyond that, the disk gradually bends. One side arches several thousand light-years above the galactic plane, while the opposite side dips below it, creating a shape that resembles a wave frozen in space. The reasons for this warp are complex, and astronomers are still unraveling them. One likely explanation lies in the Milky Way's interactions with its smaller satellite galaxies, such as the Large and Small Magellanic Clouds. These two companions orbit the Milky Way and exert gravitational tugs on its outer disk, pulling and twisting it over billions of years. Like ripples spreading through a pond after a stone's impact, These gravitational influences can distort the shape of the galactic disk, creating a slow-moving wave that persists over cosmic time. Another factor may be the uneven distribution of dark matter, the invisible substance that surrounds and supports the Milky Way. If the dark matter halo that envelopes our galaxy is lopsided or tilted, its gravitational pull could also contribute to the warp we observe today. The warp is not a static feature. It moves and shifts as the galaxy rotates, its shape constantly evolving under the combined influence of gravity and motion. The stars and gas in the outer regions of the Milky Way take hundreds of millions of years to complete a single orbit, and as they do, the entire disk undulates, creating a kind of slow, graceful dance. In this way, the galaxy is alive with motion, not just spinning and rotating, but bending and flexing as it interacts with its surroundings. The warp reminds us that galaxies are not rigid structures but dynamic, ever-changing systems shaped by invisible forces and ancient encounters. From our position within the disk, about 27,000 light-years from the center, the warp is difficult to perceive directly. To us, the Milky Way still appears as a flat band across the night sky. Yet when astronomers look outward using radio telescopes that can peer through interstellar dust, they can trace the warped shape of the hydrogen gas that fills the galaxy's outer regions. The warp even affects the orbits of stars, subtly changing their motion as they travel through space. These observations not only reveal the Milky Way's true structure, but also help scientists understand how galaxies evolve through time, shaped by the forces of gravity, motion, and cosmic interaction. To say that the Milky Way is warped is to acknowledge its vitality. It is not a static wheel of stars spinning in isolation, but a living, breathing system, bending and flexing as it journeys through the universe. Its shape bears the marks of its past, collisions, mergers, and the invisible hand of dark matter, and hints at its future as it continues to change over billions of years. When we look up at the glowing arc of the Milky Way, we are seeing the cross-section of this great, curving structure, a reminder that even in the vast calm of space, motion and transformation never cease. The galaxy we call home is not a perfect disk, but a beautiful, rippling wave in the sea of the cosmos, a celestial dance frozen in the light of 100 billion stars. The name Milky Way has its origins deep in the ancient imagination, long before telescopes revealed the true nature of the stars that compose it. For thousands of years, people have looked up at the pale, misty band that stretches across the night sky and wondered what it might be. To the ancient Greeks, it appeared as a river of milk spilled across the heavens, a luminous stream that flowed from the realm of the gods. From this vision came the name Galaxias Kyklos, meaning milky circle, derived from the word gala, meaning milk. Over time, this image of a celestial milky path became the basis for the name we still use today, the Milky Way. In Greek mythology, one story explains the Milky Way as the milk of the goddess Hera, queen of the gods. According to the myth, Zeus brought the infant Heracles, Hercules in Roman mythology, to Hera while she slept. Heracles was not her son but Zeus's child with a mortal woman, and Zeus, hoping to grant his son divine strength and immortality, wished for him to nurse from Hera's milk. When Hera awoke and realized what was happening, she pushed the child away. In the process, her milk sprayed across the heavens, forming the radiant band of stars that would forever stretch across the night sky. Thus, the Milky Way was born, an immortal trace of divine milk scattered among the stars. This myth captures something timeless about the human need to explain the universe through story. Before science revealed that the Milky Way is a galaxy made up of hundreds of billions of stars, people sought meaning in its glow. To the Greeks, it was a symbol of divine creation and cosmic beauty, an image that connected the heavens with the nurturing power of life itself. The Milky Way, born of the milk of a goddess, bridged the mortal and immortal worlds, reminding humans that the sky was not a distant void but a living, sacred realm. Even today, the poetic force of that image, the heavens as the spilled milk of a goddess, retains its beauty and mystery. Other cultures, too, created their own interpretations of the Milky Way, each reflecting their beliefs and traditions. The Romans, inheriting much of Greek mythology, adopted the name Via Lactea, meaning Milky Road, from which the English term Milky Way eventually evolved. In ancient China, the same band of light was known as the Silver River, a celestial stream that separated two lovers, the weaver girl and the cowherd, who could meet only once a year, on the 7th day of the 7th lunar month. In Norse mythology, the Milky Way was thought to be the path leading to Valhalla, the Hall of the Slain, where warriors would join the gods. Across the world, the sight of the Milky Way inspired awe and storytelling, linking humanity's earthly experience to the vastness of the sky. The Greek story of Hera and Heracles stands out for its vivid imagery, a sudden, divine accident that explains the heaven's most prominent feature. It reflects both the reverence and the familiarity with which the Greeks approached their gods. Hera, powerful and proud, reacts as any mother might, while the cosmos itself bears the mark of her gesture. The myth suggests that the universe is not distant or abstract but filled with traces of divine emotion, where even a moment of surprise or anger can give birth to stars. Today, we know that the Milky Way is not a river of milk but a sprawling spiral galaxy, home to hundreds of billions of suns and uncountable worlds. Yet the name remains, a reminder of the imagination that first sought to explain its light. Science has expanded our understanding of what the Milky Way truly is, but myth gave it meaning long before knowledge gave it form. To look up at the glowing band that arches across the night sky is to see not only the structure of our galaxy but also the echo of an ancient story, one that connects the divine, the human, and the cosmic in a single luminous arc. The name Milky Way endures as both a scientific description and a poetic inheritance, uniting modern knowledge with the timeless wonder of the stars. Surrounding the luminous disk of the Milky Way, far beyond the bright spiral arms and glowing star fields we can see, lies something vast, mysterious, and almost entirely invisible, a halo. This halo is not made of light or easily visible matter, but of dark matter, hot gas, and ancient stars that form an enormous, ghostly sphere enveloping the galaxy. Though unseen to the naked eye, it is fundamental to the Milky Way's existence, shaping its structure, holding it together, and influencing everything within it. If the visible portion of our galaxy were compared to a glowing island of stars, the halo would be the deep, unseen ocean in which that island floats, a vast and silent domain that far exceeds the boundaries of what we can see. The halo of the Milky Way extends far beyond the limits of the galactic disk, reaching distances of several 100,000 light-years from the center. Most of its mass is thought to be composed of dark matter, a mysterious substance that does not emit, absorb, or reflect light. We cannot see dark matter directly, yet its presence reveals itself through its gravitational effects. Without it, the galaxy's outer stars would fly away into space. The visible mass of stars and gas simply isn't enough to hold the Milky Way together. By studying how stars and gas clouds move, astronomers have deduced that the halo must contain far more mass than the galaxy's luminous parts, perhaps 10 times as much. This invisible halo is what gives the Milky Way its true weight, anchoring its stars and maintaining its majestic spiral form. But the halo is not made of dark matter alone. Intermixed with this unseen substance are ancient stars, globular clusters, and thin clouds of superheated gas. The stellar halo contains some of the oldest stars in the galaxy, relics from its earliest epochs, formed more than 12 billion years ago. These stars move in irregular, elongated orbits, unlike the orderly paths of stars in the galactic disk. Many of them likely came from smaller galaxies that the Milky Way absorbed long ago, remnants of ancient mergers that helped build the galaxy's current structure. Scattered and faint, they form a tenuous shell of light that surrounds the brighter regions, a stellar fossil record written across the sky. The gaseous component of the halo, though invisible in ordinary light, can be detected through X-ray and ultraviolet observations. This hot, diffuse gas forms an extended atmosphere around the Milky Way, heated to millions of degrees. It interacts with material streaming in and out of the galaxy, shaping the cycle of star formation over time. Some of this gas may eventually cool and fall into the disk, fueling the birth of new stars, while other portions are pushed outward by stellar winds and supernova explosions. The halo, in this sense, acts as both a reservoir and a regulator, storing matter, energy, and momentum as the galaxy evolves. It is not merely a passive shell, but a dynamic environment that connects the Milky Way to the larger universe. Perhaps the most intriguing part of the halo is the dark matter that dominates it. Though invisible, it outweighs all the galaxy's visible components combined. The true shape and extent of this dark halo are still subjects of study, but evidence suggests it is roughly spherical, encompassing the entire galaxy and extending far beyond the farthest stars. It may reach out nearly halfway to the Andromeda galaxy, whose own halo likely overlaps with ours. In that vast, unseen space, dark matter particles move in silence, their gravitational pull shaping the orbits of stars, guiding the motions of satellite galaxies, and defining the Milky Way's gravitational reach. To imagine the Milky Way's halo is to expand our sense of what the galaxy truly is. The glittering spiral we see through telescopes is only the center of a far larger structure, like the tip of an iceberg floating in a hidden sea of mass and energy. Our sun, and all the familiar stars we can observe, lie deep within this greater sphere, unaware of the vast dark envelope surrounding them. Though we cannot see it, The halo is essential. It binds the galaxy together, carries the traces of its history, and connects it to the invisible framework of the universe. In that silent, unseen realm, the Milky Way's true form resides, vast and eternal, reminding us that most of the cosmos exists beyond the reach of our eyes, yet not beyond the reach of our wonder. The Milky Way, with its immense expanse of stars, gas, and dust, is not merely a collection of visible matter. Woven through its vast structure, threading between its spiral arms and stretching into its halo, are powerful yet invisible magnetic fields. These fields, though far weaker than the magnets we use on Earth, extend across thousands of light years and play a crucial role in shaping the behavior of the galaxy. They guide the motion of charged particles, influence the formation of stars, and help sculpt the delicate structures of gas and dust that give the Milky Way its intricate form. Like an unseen web, these magnetic forces bind the galaxy together in ways that cannot be perceived through sight alone, revealing a hidden layer of order within apparent chaos. The magnetic fields of the Milky Way are difficult to detect directly because they do not emit light, but their effects can be traced through the radiation that passes through them. When light or radio waves travel through regions of space filled with charged particles and magnetic fields, they become polarized, a change that astronomers can measure with sensitive instruments. Using radio telescopes and data from missions like the Planck satellite, scientists have mapped the galaxy's magnetic structure, uncovering an intricate pattern that mirrors its spiral shape. These studies reveal that the Milky Way's magnetic field is strongest along its disk and spiral arms, where interstellar gas and star formation are most active. The field lines, though invisible, flow in vast, graceful curves, following the same paths as the galaxy's stars and gas clouds, wrapping around the Milky Way like invisible threads of tension. The strength of these fields is astonishingly subtle, typically only a few microgauss, millions of times weaker than the magnetic field at Earth's surface. Yet across cosmic distances, their influence becomes significant. They help regulate the movement of charged particles known as cosmic rays, which stream through the galaxy at nearly the speed of light. Without magnetic fields, these high-energy particles would simply fly off into intergalactic space, but instead they are trapped, deflected, and guided by the Milky Way's magnetic network. This invisible architecture not only protects regions of the galaxy from excessive radiation, but also affects how energy and matter are distributed over time. Magnetic fields also play an essential role in the birth of stars. Within dense molecular clouds, gravity pulls gas together, but magnetic pressure can slow this collapse, shaping how and where new stars form. When magnetic lines twist or break, a process called magnetic reconnection, they can release tremendous bursts of energy, influencing nearby regions and contributing to the turbulence that defines the interstellar medium. In this way, the Milky Way's magnetic fields act as both a restraining and creative force, balancing the energies that drive the galaxy's evolution. They are part of a cosmic feedback loop in which stars generate magnetic energy through their motion and rotation, and in turn, those fields affect the environment where new stars are born. The origin of these galactic magnetic fields remains one of astronomy's great mysteries. Scientists believe they began as faint seed fields in the early universe, amplified over billions of years by the movement of gas and stars within the galaxy. As the Milky Way rotated, charged particles in its plasma interacted with these tiny fields, strengthening them through a process known as the dynamo effect. Over time, the galaxy's rotation and turbulence stretched and organized these fields into the large-scale structures observed today. Even now, the magnetic field continues to evolve, shaped by stellar explosions, galactic winds, and the motions of interstellar matter. Beyond the disk, the Milky Way's magnetic influence extends into its halo, forming towering arches and filaments that rise above the galactic plane. Recent radio observations have revealed vast magnetic loops reaching tens of thousands of light-years into space, connecting the central regions of the galaxy with its outermost boundaries. These colossal structures suggest that magnetism may play a larger role in galactic evolution than previously understood, helping to channel matter and energy between different layers of the Milky Way. To imagine the Milky Way's magnetic fields is to picture a galaxy not merely of stars and light but of invisible forces and flowing energy. They are the unseen lines that link the smallest particles to the largest structures, weaving the galaxy into a unified whole. Though silent and invisible, they shape the paths of cosmic rays, influence the birth of stars, and maintain a delicate balance in the galactic ecosystem. In the end, the Milky Way's magnetic fields remind us that the universe is not just a place of light and matter, but also of unseen forces, subtle, pervasive, and essential to the cosmic harmony that sustains it. The Milky Way, vast and luminous, does not drift alone through the cosmic dark. Around it, like a grand monarch attended by a retinue of smaller companions, swarm dozens of dwarf galaxies, tiny, fragile collections of stars and dark matter that trace invisible orbits around our home galaxy. These dwarfs, faint and easily overlooked, are the Milky Way's loyal satellites, remnants of a long and complex history of cosmic formation and interaction. Though they are small compared to the immense spiral arms of the Milky Way, their presence tells a story of gravity's subtle power and the universe's intricate web of structure. Dwarf galaxies are galaxies in miniature. Some contain only a few million stars, where the Milky Way has hundreds of billions. They come in many shapes. Some are spherical and smooth, others irregular and stretched, and a few are ghostly, almost transparent. The large and small Magellanic Clouds are perhaps the most famous examples, visible to the naked eye from the southern hemisphere as hazy patches in the night sky. They are close enough that astronomers can trace their swirling motion and even watch as tidal forces from the Milky Way slowly distort them. These two dwarfs are massive by dwarf galaxy standards, and their proximity offers an extraordinary window into how galaxies tug and twist each other over time. Beyond them lie dozens of smaller, fainter companions, the Sagittarius dwarf, the Fornax dwarf, the Draco dwarf, and many others, each orbiting the Milky Way on paths shaped by gravity and time. Some of these galaxies are being gradually torn apart, their stars stripped and drawn into long, delicate streams that wind through the Milky Way's halo. These stellar streams are the evidence of a slow cosmic feast. The Milky Way grows not only through the birth of new stars, but by consuming its smaller neighbors. Every faint trail of stars across the sky marks the remains of a devoured galaxy, a record of the Milky Way's appetite and evolution. Astronomers now believe that the Milky Way's current form owes much to this ongoing process of galactic cannibalism. Billions of years ago, it was likely built up from smaller galaxies merging together. The dwarf galaxies that remain today are survivors from that ancient era, relics of the chaotic early universe. Some may yet be doomed to fall inward and be absorbed, while others might continue orbiting for billions of years more, like patient moons around a planetary giant. Their motions, carefully measured with modern telescopes and satellites, help scientists map the unseen dark matter that surrounds the Milky Way. This dark matter halo acts as the invisible framework that holds both the Milky Way and its satellites in place. Despite their faintness, dwarf galaxies hold immense importance in understanding the cosmos. They are simpler systems than large galaxies, making them valuable laboratories for studying how stars form and evolve in low-mass environments. Some contain stars that are almost as old as the universe itself, fossil witnesses to the time when the first galaxies were forming from primordial gas. Their scarcity of heavy elements reveals that they have experienced few cycles of star birth and death, preserving clues about the early conditions of cosmic history. When we look up at the Milky Way on a clear night, its bright band of starlight hides the quiet company that surrounds it. Beyond what our eyes can see, the sky is dotted with these fragile galaxies, some bright enough to be found with small telescopes, others so faint that only the most sensitive instruments can detect them. Together, they form a vast and ancient family, bound by gravity and shared history. The Milky Way may seem solitary in the night, but it travels through space accompanied by these silent companions, each one a tiny spark of the universe's grand story, circling endlessly around their colossal host.